Denton. I actually worked with Max at Miranda many years ago as well, and I know some of you have worked with him at XaaS and Miranda. Max is going to present tonight a talk on transitioning to a service-oriented broadcast infrastructure. And I know Max has been doing a lot of research into these types of technologies, and this is a somewhat of the presentation that he did at NAB last month. So I think it's going to be really interesting. Max is a product manager here, and he's in charge of our media processing platform, kind of the core infrastructure of Vantage. His background is in traditional broadcast engineering, and he has experience developing next generation products, and that's taken him to broadcast and production facilities around the world solving problems. I remember at Miranda, Max was kind of the guy that, you know, when nothing was working right and nobody could fix it, he would put the cape on and fly in and make stuff work. So, and then he would come back and bug all the product engineers about, all the product managers about stuff that needed to be fixed in the product. So I'm going to turn it over to Max and take it away.
All right. Thanks, Scott, and it's nice to see a lot of you again. It's been a little while. What I want to talk about tonight is this notion of anything as a service or software as a service, infrastructure as a service, get into what some of these offerings look like, and really more generally these notions of abstraction and machine virtualization, or virtualizing away the hardware layer. As Scott mentioned, you know, this is a topic that we're seeing. This is really very mature technology from the IT industry, but that is rapidly taking off and displacing more traditional technology in the broadcast industry. So before we get into virtualization and abstraction, we really have to start with appliances. And so what do I mean when I say a appliance for our industry? Well, I don't mean a washing machine. What I mean is something that's a purpose-built, dedicated piece of hardware or application that performs a specific task, and that it does it with little or no dependency on an underlying platform or framework. Basically, this is something that's standalone. It's a box that performs some function. And of course, in broadcast engineering, appliances are used all over the place, and they're really just the evolution of standalone hardware devices. If you look at a set of drawings from a broadcast customer, broadcast facilities, typically they look something like this, with lots of boxes and lines going between them. And each box represents, again, this particular function. And the lines often represent signal flow. And as broadcast engineering has evolved into a lot more than passing video around, has evolved into control and metadata and monitoring, a lot of these systems are modeled the same way. You have some box, it lists what it, you know, with a label telling you what it does, and a line drawing to another box. And again, this comes back to this key concept that the engineering from the customer, from the broadcaster's end, is really based around devices that stand on their own and perform a specific function. And increasingly, these appliances are software-based. Now, some of these are using hardware acceleration through PCI cards, or using PCI cards to, you know, input and output video into baseband, but particularly with packetized, essence-based IP video, even that's going away. And many of these systems are entirely software-based. And not to mention systems that don't even touch the video at all. So again, think control systems, monitoring, schedule, traffic, automation. These are really just pieces of software that are running on standard Windows or Linux operating systems and running on top of commercial off-the-shelf x86-based hardware servers. Now, a lot of times these servers are resold by vendors and rebranded and sold as, again, a turnkey appliance. But at the end of the day, it's still a computer. So that brings me to my next point, which is that these are really just computers in disguise. You know, we've all seen the rack rooms at broadcast facilities full of 1 and 2 rack unit boxes with lots of bezels from lots of broadcast vendors. And all that's under the cover is a bunch of x86 computers running operating systems, running applications. And one of the reasons this model's been so successful is because they've avoided the management of the IT department, which has worked out really, really well for the broadcasters who seem to have a lot of friction with the IT department within their organizations, who don't feel they understand their needs. And so they've maybe avoided having these systems be part of the corporate IT management scheme. But at the same time, they failed to capitalize on any of the benefits of data center technology, any of the benefits of virtualization and abstraction and the efficiency and the flexibilities that come with that, which we'll talk about. But first, let's finish talking about appliances, because people seem to really like this notion of a 1 or 2 rack unit server with a piece of software installed on it that we call an appliance. And the developers who write code, some of you like them, broadcasters, the end users like them, vendors who sell all this stuff like us like them. And so why is that? The developers like them, I believe, because of control for resource contention and dependency control. So for resource contention, most of these enterprise applications are written with the mindset that you have control of the entire compute platform, and you don't have to share those resources with any other application. Now, this is something that software designers in the consumer industry have to cope with, that whatever performance and resources are available to them is what they utilize. But particularly in broadcast, most of these applications are depending on having a fixed set of resources always available. They like that these boxes have a specific function, that they're always on, and that they have dependency control. Increasingly, with the rapid development times of software, they're built on top of things like .NET and Java, where there are specific C++ libraries that need to be installed, not to mention OS versions and patches and drivers. And so knowing that this thing ships from a vendor as an appliance with all that pre-installed, and they have control over that, and they're not going to have to fight with another application in that same hardware environment, is another great reason that every time that broadcaster needs one more application, they end up with one more 1 rack unit box. Of course, it simplifies testing as well. You can hand the whole thing off to the QA department and they can test it. Broadcasters have a whole bunch of reasons why they like these things. Obviously, familiar designs. We've somehow managed to have broadcasters really designing software-based systems like their hardware. And the appliances tend to help them do that because of their standalone nature. Simplified failure blocks. There's something really reassuring to a broadcaster that knows if you pull the power on this box, they know exactly what it is that's going to fail, because the definition of that application is wrapped up around that box. Minimal system interdependency, we talked about that. Simple redundancy, we've all seen the pair of 1 or 2 rack unit boxes, 1+1 redundancy with a failover scheme. And it makes troubleshooting easier. And of course, there's a single throat to choke. Single vendor support, whether it's a hardware or a software issue, you call up that vendor. And the vendors like them, because there's guaranteed performance, particularly if there's something where there's a real-time performance involved. You know the results you're going to get because the hardware left your factory. Also, simplified supportability from the vendor's perspective. Generally, there's a pretty good chance when you're talking to that customer, that machine is in roughly the same shape it was when it left the factory in terms of things that are installed, those dependencies, operating systems, and so on. So that all sounds really great, right? So why move on? Why end a good thing? Well, IT, particularly when we talk about all these things for developers, all these reasons why we keep throwing in one more after another 1 rack unit appliances every time a new application is needed. IT's had the same problems. And I'm not just talking about the IT department that, cleans the viruses off your laptop and sets up your email, but enterprise-grade IT that's often serving millions of users via cloud applications, often with quality of service requirements that are as high or sometimes higher than those of the broadcasters that, in our industry. IT's had all those same problems and has achieved gains in efficiency, scalability, and reliability by moving to virtualization and cloud-based technology. And this is a really important point to me. This is something that I always found a little comical, that over the last few years, I think every one of us has been involved with this transition to real-time video production, right? Over IP. So whether this is 2022-6, whether it's, 2110, packetized IP-based video. And this is fantastic because now instead of rigid SDI infrastructure and cables and BNC connectors, we now have the flexibility of these commercial off-the-shelf network fabrics. It's more cost-effective, it's more flexible, all these really interesting design options open up. But really, what's the point of this super flexible plumbing and this super serviceable and migration-friendly plumbing between rigid appliances? And that's where a lot of the industry is today, is that there's been a tremendous amount of focus on the transition to video over IP, where a lot of the applications, in particular applications that are supporting with control and metadata and scheduling roles of that IP layer, are still deployed as rigid boxes. So what does the future look like? Obviously, today we have these standalone appliances. Tomorrow, or a transitional step, or the final step for many customers may simply be virtualization, which we'll talk more about. The notion of being able to run one, or in many cases, multiple copies or multiple appliance instances inside of virtual hardware, and to get those benefits in efficiency and in flexibility. And then, of course, there's the cloud. And when I talk about the cloud, whether it's public cloud or private cloud, there's really two main cloud offerings, cloud services worth considering. And the first is software as a service. And of course, most of us encounter this every day with some consumer software as a service application, but it cuts out the appliance altogether. It lets the vendor deliver to the end user what it is the vendor is good at doing, as opposed to a tool or an appliance for the customer to do that themselves. And so with software as a service, whether it's transcoding, whether it's control, whether it's automation, everything is abstracted away. The hardware, the appliance, the application, and the user simply gets the service. Infrastructure as a service is a way that compute infrastructure can be used either in a public or a private cloud, so that we can continue to have these appliances, but as opposed to having to run them on discrete pieces of hardware, you utilize infrastructure that's available in the cloud to support what that appliance would have done. And so the first thing I want to talk about is virtualization. Virtualization is not a new piece of technology. It's exciting and new, honestly, to many of the biggest leading broadcasters in the world are now making large migrations onto virtualization, but it's nothing new. IT's been using it since the late 90s. I think this is a pretty conservative figure, but somewhere around 3/4 of all the computers in the world are actually VMs as opposed to actual servers. They're running in a virtualized environment. And virtualization is really the foundation of all these other pieces of technology. It's the foundation of data center management, or of managed virtualization, which gives us the flexibility to migrate machines around and to load balance in an efficient way. It's the basis for containerization, which is the notion of, instead of having to run a virtual machine, you actually just run this thing called a container, which allows you to have all the resource and dependency control, but without an operating system. Really cool piece of technology that I don't have time to talk about tonight. It enables, of course, the notion of the cloud, this ability for infrastructure as a service providers or software as a service providers to be able to deliver wholesale and rapidly scale applications or infrastructure they deliver to their end users, and to be able to do that on top of their virtualized data center. And then these last two pieces are, I don't think, quite yet applicable to our industry. But there is really the notion that, if you think about a company that's developing a piece of cloud software that's interfacing with the end user directly. In the traditional model, you have development and you have operations. So development writes some software, operations puts it on some servers, maintains those servers, and that's how the users access it. And every time they want to make a change to that, well, development has to make a new release, it has to be QA'd, it has to be rolled out by production, and you end up with pretty long life cycles. Well, with software-defined infrastructure, if you have all of these pieces in place, which means the infrastructure is now automated and can be controlled programmatically instead of by humans, now the developers and the development team can actually write code as part of their deployment tools that defines the infrastructure that's needed to roll out the application. And so the whole notion of DevOps is to blur that line between the development team and the operations team. Instead of the development team building a release that then gets installed by operations, development just defines the infrastructure and puts it straight into production with the help of the operations team. And so this is some of the technology that's empowering the really rapid development that we see in consumer-facing apps today, because they've really cut out that middleman of, that middle point of actually releasing the application. But for the rest of the evening, I want to focus back in this neighborhood a little bit about machine virtualization, data center management in both public and private cloud, because this is something, again, we're seeing many of the broadcasters very aggressively moving towards these models. And one thing I want to clear up about hypervisors. So obviously the hypervisor is this piece of software, this host that allows us to run virtual machines in a VM environment. And the type of hypervisor we've all probably encountered is a type 2 hypervisor. This is where you have a bare metal, a piece of hardware, an operating system, some applications running on top of that operating system, and then you have your hypervisor. So maybe this is Parallels on your laptop or VMware, And then inside of that, you're running your VMs. And I believe that this setup right here has really led to the notion that VMs are slow, that VMs can't guarantee resource allocation, and because in those type 2 hypervisor setups, they can't. Because you've got this operating system and all of these operating systems stacked on top of one another, competing for resources. And it doesn't lead to a dependable set of resources being passed to the VM. Well, type 1 hypervisors are the type of hypervisors in an enterprise-grade installation. So these are available from VMware, from the Zen, which is the Linux open source community, and Hyper-V all have type 1 offerings. And when we're talking about enterprise virtualization, the kind of virtualization solutions that broadcast facilities would use, they're based on type 1 hypervisors, where the hypervisor is installed directly onto the bare metal. And the most widely used example of a type 1 hypervisor is VMware ESXi. That's probably has a large majority of the market share in the industry. And with this hypervisor, since the VM runs directly on top of the hypervisor, there's not this extra operating system sandwiched in the middle and these sort of awkward transactions needing to be brokered back and forth. And the efficiency is much higher. So in a type 1 environment, at least based on this report, it works out to, on average, for general compute operations, about 96% efficiency. About 4% of the compute resources and memory resources are put to waste with that hypervisor in the middle. And that's kind of the tax you pay for that flexibility or maybe that efficiency of being able to run multiple VMs on a piece of metal. And the more we talk about the benefits we get out of this, I think 4% is a pretty good bargain, particularly with the rate at which compute is constantly increasing. Well, we did a little test here at Telestream where we took a piece of bare metal with an operating system and we transcoded some video on it. And then we just slipped a hypervisor in the middle. Same software, same operating system, same hardware, everything else. And we did a real-world test using the same files, and sure enough, they transcoded 3 to 4% slower. And now these times are a little optimistic when it comes to real-world operations that involve millions of files and trillions of micro-operations. That's where the tax gets a little steeper. But particularly for compute-intensive things, a type 1 hypervisor is really amazingly efficient. Now, the hypervisor, or the ability to run a virtual machine on top of a server, well, that's really just a computer inside of another computer, right? And at best, it's multiple computers inside of one other computer. So what did we really achieve? Well, the power and the flexibility starts to really come in with a management layer that's applied on top of these hypervisors, that's applied in this environment. And so we start with unmanaged virtualization. So this is just a bunch of servers with a bunch of hypervisors running a bunch of VMs and some guy who manually manages all of this. Managed virtualization is where now whoever that person was is replaced with a piece of software that has an overarching view of the virtual machines you're trying to run and the hardware you're trying to run, and it optimizes that environment for you automatically. We'll talk a little bit more about that. And then really the end game is a private cloud. And so now in a private cloud, in addition to the compute being automated, the storage and the network configuration and the management of images all becomes automated, such that the user experience, or whoever the intermediate person who needs this piece of infrastructure to run an application, can have it provisioned in a couple of clicks. Compare this to taking a server out of the box, wiring it up, provisioning networks. Potentially days or weeks long process can be done in a couple of clicks and fully automated in a private cloud. And as with anything, as we apply more management, it gets more complex. To deploy one of these private cloud solutions inside of a facility is hideously complicated. But what it gets you is in a very decreased number of steps in order to deploy new instances, which of course for media companies that are trying to rapidly deploy new projects all the time, this becomes really important. And as I mentioned, the integration of infrastructure systems. Back here, the systems, and what I mean by that is compute, the hypervisors, the servers, the shared storage, the networking, they don't know much about each other. And by the time you get to here, by the time we're talking about managed virtualization, they know slightly more about each other. And only until we get to the private cloud are all of those systems integrated and orchestrated together. So let's take look at a couple of examples of this. So in unmanaged virtualization, we have somebody who needs to spin up some infrastructure in order to run an application. So this is a broadcaster, they want to put a new project on the air, they need to get a set of infrastructure spun up to do that. So he's going to send a request, in this case to our blue fellow here, and that infrastructure request is probably an email, right? And he's going to define that he needs some machines, running some operating systems, the kind of resources he needs for those machines, and he's probably also going to give this guy an idea of just how critical of an application this is. And now this guy is going to go out, and remember this is unmanaged virtualization, so this is where he's got a bunch of hypervisors on a bunch of servers, and he's going to pick, based on that infrastructure request, where he thinks those virtual machines can be run. And he's also going to make a decision about whether or not he's going to oversubscribe or undersubscribe his resources. And so if this guy said, well, this is really important, I need this many CPU cores at this many gigahertz and this much RAM, and it can never, ever, ever slow down, then this guy's going to undersubscribe. He's going to find a hypervisor and a piece of hardware he can put that VM on and know that it'll always have those resources available. Now, if that's not the case, if this is something that could maybe handle to be slowed down from time to time, and that he doesn't really think that guy means it when he says, yeah, I need 48 cores and 16 gigs of RAM, but he has a feeling that application is probably going to use 2% of that most of the time, then he's going to be more tempted to oversubscribe and to put multiple VMs onto the same pieces of bare metal, onto the same hypervisors, and oversubscribe those resources. Which means that the VM, when it looks down at what it thinks is the hardware, it thinks I have all of those resources I asked for. And only if it calls the bluff and tries to run up the CPU or the memory usage that high, will it ever find out that it doesn't really have those. And just so you know, the number in the IT industry is 5 to 1. 5 to 1 oversubscription is actually the standard in data centers, that each one of the VMs looks down and it sees a set of what it believes is hardware, and usually only about 20% of that is actually provisioned. And so either way, the blue guy has to manage that. He also needs to configure the shared storage. He also has to configure networking. He also needs to deploy the application, manage the operating system images. And this sounds like a lot of work, but remember, he didn't have to take anything out of any boxes. He didn't have to put anything in any racks. He didn't have to hire the union labor workers inside of a broadcast facility. Suddenly, something that used to take days or weeks now is a couple hours work, but there's still a lot of manual management involved. Well, this one in the middle, which is honestly the sweet spot that I see a lot of broadcasters going for, uses a virtualization management system. And the best example of this, the one most pronounced in the industry, is VMware vSphere. Again, this is a very mature piece of technology with tons of installations all over the world. And VMware vSphere takes that pool of resources, takes all of these servers, usually blade servers, running hypervisors, and pulls all of that together into a common system, such that based on the infrastructure request, the blue guy can just simply tell the virtualization system, my VM needs this many CPU cores, it needs this much memory, and I am or am not serious about those requests. And that comes down to the notion of a reservation. He can either say, I want you, Mr. Virtualization System, to reserve all those resources, whether this guy is going to use them or not, which would be the undersubscribed model, or he would say, no, find the most efficient way to do it, in which case this system will automatically monitor the CPU usage of that VM and constantly determine the most efficient place to put it, and it will manage all of the oversubscription. And if that application ever calls the bluff on the oversubscription, that application that we thought, yeah, look, most of the time it's only using 5% of the CPU, we can stack loads of those VMs on this particular hypervisor. And then one day, one of those VMs does need all of those resources. Well, the management system, dynamically, whenever this can happen, will respond very quickly to actually do a live migration of that VM onto another piece of hardware. And I swear, I'm still entirely convinced this technology is pure magic. I have no clue how it works. I just know that it does work. And I've watched it work, and I still don't believe it. But it will take a running VM and migrate it from one piece of hardware to another by synchronizing the memory before it does it, utilizing a high throughput backplane of usually a 10 gig network, and by coordinating between those hypervisors. And once it realizes that that VM needs those resources, it's simply going to find someplace else to put it that can deliver those resources. And so what you get by having this constantly rebalancing and provisioning how the VMs are allocated across it, A, is a lot less steps for this guy to provision, but B, leads to even more efficiency of getting more and more of these one rack unit servers running on top of each one of these blades. And if you think about all these one rack unit servers that are running at a couple percent CPU, running a fairly minimal application, only because of dependency control and vendor supportability and everything else, you can imagine these claims that a lot of broadcasters are making about how server rooms can be reduced folds on folds down in terms of square footage because of the efficiency they'd get out of that system. It's worth noting in this case that the blue guy is still configuring the storage, he's still configuring the network, he's still configuring the application, but now all the compute's been automated for him. The last one is private cloud. So in private cloud, this is where now a cloud management layer does everything. It does all of this. It's aware of the storage, it's aware of the networking, it's aware of that automated hypervisor system, and in some cases even of the applications. And so now the provisioning is much, much simpler, and all of that automation can be handled inside that system. Which leads to the question, well, do we really need the blue guy to be in the middle of this transaction? Maybe if there are people inside of the organization who need to spin up infrastructure, they can interact with the cloud manager directly to do this. And I don't know if any of you have interacted a lot with Amazon AWS web services, but if you have, it's the same process for a private cloud. You go in, you tell it you want a VM, what the resources are you need, what operating system you need. 4 or 5 clicks later, that VM is up and running and accessible to you. And it's that kind of automation that a cloud manager brings, even if it's in a private cloud environment. And as I mentioned earlier, again, now that this is so automated, maybe instead of that infrastructure request being an email, maybe now it's an API and driven by code, which means maybe now the green guy is our developer. And as he's writing the software, he's actually defining the infrastructure needs into the software. So we talked a lot about all the benefits and why we would do all this, but there's a couple I want to review. The hardware utilization is probably the one we all hear the most about, right? We want to go from racks and racks of servers to a blade chassis, and we want all the efficiency that comes with it. And everything about, particularly a managed virtualization system, realizing the real compute needs of all of those VMs as opposed to just their over-provision needs, leads to a lot of VMs being able to be combined on each one of those pieces of hardware, which of course means to a broadcaster there's less money spent on hardware. But the real savings, I believe, is down here. It's less hardware to cool, it's less hardware to install, it's less hardware to buy real estate for, and those are really where the cost savings get massive. If you think of the real true cost for every rack of servers, these 5-to-1 or 10-to-1 or 100-to-1 reductions in rack space based on that efficiency is huge. Another one is standardization, right? Now with most of these broadcasters are moving to a single hardware platform. They don't want a whole bunch of hardware from a whole bunch of vendors that all need spare management and replacement. Now if all of that hardware is generally the same model of a generic blade chassis, and all of the specialization of what the broadcast vendors are doing lives in the application layer, it now means that one of those hardware failures, one of those modules fail, there's a whole room full of spare modules, you take out the bad one, you put in the good one, the system heals itself and does the rest. So the standardization not only is much more efficient to an end user from a cost perspective, but also from a maintenance perspective. With the management layer on top, we get a lot of benefits like portability. Now that the management layer is able to move these VMs around so easily, it can actually move them between geographies, between data centers, based on putting them the closest to the data they're trying to manipulate. If a broadcaster is trying to spin up a new project in a different city, now they can take one set of infrastructure, one set of applications that was being used for something else, as opposed to rebuilding that all in the different city. They just migrate the virtual machines. And for disaster recovery, this gets really interesting. As opposed to the way we tend to do disaster recovery today, where you build another facility with some subpar equipment that's constantly not configured the same way as the main facility, what if that other facility just had infrastructure and the applications just had to be moved based on backup images in the case of a disaster? So disaster recovery gets a lot more interesting. Ease of deployment, I think we've beat that horse. We've talked about that this is a software task and not a physical task, and an increasingly automated software task at that. And finally is elasticity, right? This notion of broadcasters, they have peaks and valleys in their business cycles. They have things like busy news days and elections and promo seasons, right? And sports events. And they want their systems to be able to grow and shrink appropriately. And this is pretty impossible to do if they're all based on 1 or 2 rack unit servers. If you have one day that there's something, let's say, busy in the news and there's a whole lot of transcoding or rendering or video processing operations that need to be done, well, you're not about to order up a bunch of servers, get them installed, and then send them all back the day after that. But if now, instead of server rooms full of a bunch of discrete servers, you have a centralized piece of blade-based infrastructure that's slightly over-provisioned, and particularly, you can find some other application within your organization that maybe doesn't need as much infrastructure that particular day when you had all that video to process. A managed virtualization system can spin up those VMs, migrate them across the physical host to find the most efficient place to use them. I mean, we're talking about something that can happen with a dozen clicks and in 5 minutes. And that ability for these systems to grow and shrink is really powerful. Now, one thing I hope you probably noticed was that my increased hardware utilization thing is probably a little bogus if you're doing transcoding or rendering or anything like that, right? Makes a lot of sense for these control or monitoring applications that are at 1% CPU all day, but what about the stuff that isn't? What about the stuff that's soaking up all those resources? Well, why would we virtualize anyway? This is something I hear a lot, and I like to remind people that, yeah, you're right, the software already saturates the bare metal. So you would have, at what first glance looks pretty ridiculous, is bare metal, a hypervisor running a single VM on it. You're probably asking, why don't I just install that operating system on the bare metal, get back that 4% CPU performance that I lost, and do it that way? But all of these other benefits, the standardization, the portability, the deployment, and the elasticity, are really the benefits that I think, in a way, are more powerful than the hardware utilization. So there's a huge cost savings for a lot of those other applications, but even for the ones that saturate it, there's a tremendous flexibility play as well. And so next, now that we've kind of talked about virtualization, that brings us back to the cloud. Back to these acronyms of software as a service or platform as a service, infrastructure. People keep making stuff up using this letter for whatever that creative thing is that they want to deliver as a service. And so what does this really mean? Well, I tend to get a little hung up in the definition of this, that when something is referred to as a service, it's often a commercially available service sold with some kind of a subscription model. And this is the important part, where the underlying dependencies are abstracted away and hidden from whoever is consuming or using that service. And sometimes this refers to inter-organization or even intra-system services. So now, instead of just one cloud provider providing a service to an end user, a lot of big organizations are seeing the efficiencies in having a private cloud and providing those services internally, using the same kind of demarcations and contracts that you would if it was an external customer. Now, this is, of course, all powered by virtualization, containerization, orchestration. But so what do these offerings really look like? The one that we probably most encounter every day is software as a service, right? So think your CRM system, think Salesforce. You log into this, you don't know what server it's running on, you don't own that server, you don't pay that server, you don't fix that server. All of the server, the hypervisor, and even the application is all abstracted away from you. All you see is the end result and the functionality, which also usually means you don't get to customize all this stuff that much either. But ultimately, that's all hidden from you. In infrastructure as a service, and the best example of this is Amazon AWS, the metal, the hypervisor, and the operating systems are hidden from you, and what you get is a computer. You say, I'd like a VM running this operating system with this amount of performance, and then on top of that, you have control of the dependencies, the application, and the functionality. And this is a great way, by the way, that organizations can move into utilizing cloud-based resources without having to ditch all their applications and having control over customizing those applications. You'll notice back here that the application's grayed out because I don't get to control it. I don't get to customize it. It's not something I'm managing any longer. And then platform as a service is in the middle, and this is back to that containerization technology that we're not going through tonight, but very similar, that now instead of the deliverable being a computer with an operating system, it's a container which still allows the execution generally of Linux-based applications, but without an entire operating system. And so whatever piece of offering we're talking about, whether it's infrastructure, platform, or software as a service, it of course can be offered as a public or a private cloud. Obviously, a public cloud is an external provider, and the power is usually that it's offered to many customers, right? It's that data center is chocked full of thousands of servers serving millions of VMs to millions of end users. Private clouds are internal offerings where we get that same functionality, that same automation, that same efficiency, but as an investment that's owned or managed by the end user. So and of course, public versus private cloud, this is a topic that's up for debate with a lot of end users right now. But just a quick few points to think about. Obviously, a public cloud, this is OpEx, right? You're going to pay for this by month, by year, often by hour based on computing time, whereas private is still capital expenditure. It's still a big investment that a user is going to make so that they have those resources under their control, and obviously don't have to pay any fees to use them. With public clouds, there's bandwidth concerns that if you're doing a lot of processing up there, that's a lot of media you got to move around. And in many cases, there are data sovereignty concerns, particularly in Europe. There are a lot of laws that say a piece of media isn't actually allowed to leave that country. And if you put it up in a public cloud, there's a pretty good chance that'll happen. So that's compared with private cloud, where everything's within your facility, that can be a concern as well. Their security versus your security, there's a huge debate about this. In a public cloud, you're trusting somebody like Amazon or Google to secure your data, whereas in a private cloud, you get to do it yourself. And so the question is, who's going to be better at it? I can tell you a lot of people are having a lot more trust in someone else than themselves to secure their data, and that's a change. That tide has changed a lot in the last couple of years. Scaling, with public cloud, you can scale seemingly endlessly. You could go to Amazon or Google Cloud and ask for as many machines as you want, and as long as you're willing to pay for them, you're going to keep getting them. With private cloud, at some point, you're going to bump up against the end of all that infrastructure that you were willing to purchase. And then lastly, we talked about with public cloud, all those things, all those boxes that were grayed out in our infrastructure as a service offering, we didn't get to customize. You don't get to control what kind of hardware that is. You don't get to control the GPUs or the processors that are used underneath. Whereas in private cloud, since you're making the investment, you can control all of that. So that's kind of my overview of this technology. And the last thing I wanted to talk about was just a few practical considerations, because a lot of people are looking at this technology and it seems, okay, that's great, that's awesome, but it seems way out of reach. It seems like a huge transition to move to an all public cloud or an all private cloud-based solution. And particularly with public cloud, it's a lot easier than you'd think. You can sign up right now with a credit card and a few dollars and be spinning up servers in AWS in the next 20 minutes. You can do the same thing in Google Cloud. And in order to utilize these as part of, in the case of a broadcaster, as part of their infrastructure, there are a few steps, a few things that personally I've found that can make this really easy. The first thing to talk about is redundancy. Obviously, broadcasters love redundancy. And there's two things they're really protecting against. One is some kind of a hardware failure, the computer, the disk, the power. The other is a software failure, right? The software crashes, it's got a bug, data corruption, the operating system tips over. And we're used into traditional appliances, right? These are those two one rack unit boxes sandwiched right next to each other, and being protected against both of those things. We have two operating systems, two applications, two servers, hardware and software redundancy. It doesn't matter what fails. As long as the failover happens, you can be up and running on the other server. And in unmanaged virtualization, so remember this is back where you're managing discrete servers with discrete hypervisors, well, you can do exactly the same thing. It's no different. Just make sure you put the VMs on different servers. Otherwise, you don't achieve the hardware redundancy. But in a managed virtualization or in a cloud environment, particularly something like AWS, since it's utilizing this cluster technology, right, this fact that it's gluing together all of these different servers and all of these different hypervisors, and you don't even know or need to care which one your VM is running on, you get hardware redundancy without having to double up on the servers. If this server fails, it's simply going to migrate the VM somewhere else. And oftentimes it can do that proactively, and worst case scenario, since the data doesn't actually live on the server, it can do that with really minimal disruption. But it's worth noting in that case that if that operating system or that application becomes corrupt on that VM, all the servers in the world don't help you out of that problem. And so there's actually a case to achieve the same redundancy, where as silly as it seems, even though you have a cluster with high availability and full redundancy down here, you're actually going to want to run multiple VMs in that environment so that you get both the hardware and the software redundancy. The good news is if your backup VM is hardly doing anything at all, your management system is going to be smart enough not to let it chew up a bunch of server space in order to do that. The next thing I want to talk about is APIs. So up here I have my VPC, as it's called, a virtual private cloud. Let's take the Amazon example. So in Amazon, if I have a bunch of servers I want to spin up there, I create this little thing, a few clicks, it's a VPC. It's a private network that I have running in Amazon's data center. And then, but I've still got my network. I've still got my operators on the ground. I've still got computers on the ground, all these things within the facility. And generally the approach, the most efficient approach, the most forward-thinking approach is to use APIs that are designed for the public internet. Ones that are designed to tolerate latency and bandwidth slowdowns, that are inherently encrypted. And this is great unless your application doesn't have those sort of APIs built into it. And this, again, can be one of those barriers that stops people from investigating this technology. Well, the good news is there's a pretty simple solution, which is to establish a VPN connection between that network that's up in the cloud and that network that's on the ground. This is surprisingly easy, and you'd be surprised, most broadcast customers already have one of these established with a public cloud provider like Amazon. And so once you establish that VPN, then your network really becomes their network. And so now you can spin up virtual machines up here, install your software on them, and it's as if they never left the building. The only difference is there's a little more latency across that network connection, but all the ports are available. There's no security concerns. Those protocols can be as insecure as you like because they're secured inside of the VPN. They're still subject, of course, to the security of that VPN and of the virtual cloud provider. But this is a really common strategy, particularly in IT, to avoid migrating to all these new APIs and user interfaces and away from thick clients to web browsers. That's a huge hurdle in a lot of cases. And the VPN is a great approach for people to start experimenting with using public cloud. One note about that, though, is that latency I mentioned. The latency to public cloud can be amazingly low. To ping round trip from here to the nearest AWS data center in Silicon Valley is 8 milliseconds. Out of this building and back to traverse the entire network fabric. That's very, very low. It's 100-some milliseconds to the East Coast, and it's 300 or 400 milliseconds to Europe. And that doesn't sound like a lot, but depending on what protocol you're using, that can stack up. And that's where some of those more next-generation forward-thinking APIs have advantages. So one is, let's consider moving a 1 megabyte file. If we were to move that file over an HTTP file transfer like S3 or WebDAV, one of these object-based file transfer, kind of next-generation technology, there would be one handshake transaction. So to make the math easy, let's say it's 100 milliseconds round trip, there's going to be 100 milliseconds where the bits aren't flowing because we're waiting for the hands to shake. We're waiting for that round trip. Well, if we were to do that same 1 megabyte file over SMB, so this is regular old Windows networking file share, which again could be really easy to set up inside of that VPN environment, there's going to be 19 of those handshakes, or about 18 per 1 megabyte, plus one initially. And so that's, in our 100 milliseconds example, 1900 milliseconds, right? That 1.9 seconds that no bits are actually flowing for every megabyte of file that gets moved. And so for something that's particularly file intensive like that, that's why these APIs exist. And they tend to solve the security problem while they're at it. But that being said, particularly for things like control, things like automation that maybe aren't dragging around such big files, establishing that VPN is a great way to get started really quickly. Lastly, I want to talk about centralized configuration for the application layer. So today, a lot of applications out there use discrete configurations. So wherever the executables run, alongside of them are some kind of configuration files, text files, databases, registry entries. Doesn't seem like a problem in an appliance-based environment, but now with dynamic instances in virtualization, we talked about elasticity, we talked about scaling, we talked about that busy news day, right? Suddenly they need some more instances of whatever that application does. Well, if you spin those up, great, that can be automated, that can be done with a couple clicks. But if the configuration files live right there alongside the executables, this guy's got a lot of configuration to do. Best case scenario, this guy's got a lot of scripts to write. Well, centralized configuration is really the king when it comes to scaling, when it comes to elasticity. That somewhere there needs to be a database that persists, that lives all the time, that's got the instruction of what that set of applications, what that tool needs to do. Such that when it needs to be scaled, it's as simple as spinning up additional copies of these applications, utilizing that flexible infrastructure to do that, and as soon as they come to life, they talk to that database and they know exactly what to do. This is the difference between applications that are being used in virtualized environments for the scaling and ones that aren't. So something to consider there. And finally, I'll close with this. There's also some human beings involved here. And if you look at how most broadcast facilities are laid out, it's going to look something like this, where you've got all these different discrete departments, and they've got different people managing them, different engineering teams, typically a whole lot of politics between these people. And each one is sort of laid out in a fairly linear fashion, right? We talked about those blocks on the CAD drawings, all these standalone pieces of infrastructure, which are just appliances, just running applications. And at best, you've got video and maybe a little bit of control or networking flowing between these departments, but they're really operating as islands. And this paradigm is really kind of outlived its usefulness. And particularly if you think about the notion of consolidated shared infrastructure, how silly would it be if each and every one of these guys bought a bunch of servers and bought VMware and built themselves a private cloud, and this guy's got a private cloud, and this guy's got a private cloud, just so they can host their own applications? It doesn't make any sense at all. And honestly, this is another reason that holds broadcasters, holds end users back from this technology. So the ones who are successful about it have found a way to kind of turn that picture on the side. They found a way to look at the infrastructure needs across their entire organization and put somebody in charge of offering that. And to look at their media management and their their storage needs across the whole infrastructure and their control needs across their whole organization. And what that does is it allows these guys and these departments to focus on the applications that they need to deploy. And now as they deploy those applications, they can do that rapidly. They're doing this on that shared infrastructure, which means all those efficiencies we were talking about of multiple VMs running on servers and VMware magically consolidating them when they're not in use, all of those efficiencies apply across the whole organization. And again, these folks are able to roll out applications really rapidly because they're standing on the shoulders of a shared piece of infrastructure. So this is another thing that, again, those organizations that are looking forward, one of the transitions they're having to find is to look really at this vertical software stack, the same way systems architects in software environments do, as opposed to that more traditional left to right paradigm. That's all I've got.